Hello, my name is Josie West, and today I'm going to be going over how to determine the energy/heat of a freezing curve process. This question is asking if you have 155 grams of water at 32.5 degrees Celsius, how much heat in kilojoules is involved in the process to convert all the liquid to solid at negative 5.5 degrees Celsius? So the first thing that jumps out is that we are going from a liquid to a solid, which means that this is going to be a freezing process. So we should create a freezing curve to help visualize what's going on, which I did right over here. And so looking at the information that we're given in the problem, we see that we are starting at 32.5 degrees Celsius. So I put us over here starting at 32.5 degrees Celsius at part A. Now, we are obviously going to be cooling because we are going from liquid to solid and we are freezing. But we are not going to go directly to negative 5.5 degrees Celsius because we actually have to go to the freezing point of water first. And that's going to be 0 degrees Celsius. And this needs to happen because there's going to be a whole segment of heat that is generated during this process itself where the temperature is remaining constant at 0 degrees Celsius. So essentially, the way that we can think of understanding how much total heat is generated is that the Q total, which is heat, is going to be equal to the first segment when it's first cooled from 32.5 to 0. So we can call that Q1, which I put over here. And again, that's going from 32.5 to 0, plus Q2, which is the heating/cooling that is occurring from point B to C at the freezing point. And then finally, the heat that's generated when we're going from 0 to the final temperature, which again is negative 5.5. So the first thing we're going to want to do is we're going to want to find the heat for Q1. And to figure out which equation we're going to want to use, we need to see what's actually going on in this segment. And what's happening is there's going to be a change in temperature, obviously. So we know that we're going to want to use the equation for heat that involves change in temperature. So we can say that Q1 is equal to the mass, and we're given the mass of 155 grams, times the specific heat. And because we know we're starting as a liquid, because it says water, we can look for the specific heat of liquid in our reference chart, which is 4.18 joules per grams degrees Celsius, times the change in temperature. And we're going from final to initial. And remember, again, our final temperature is not negative 5.5 degrees Celsius for this segment. It's just going to be 0 degrees Celsius because that is our final destination for this particular segment. And then our initial temperature is going to be 32.5. So when we plug that into our calculator, we get that Q1 is equal to negative 21,056.75 joules. And we can figure out these units because the grams cancel out the grams, and then the Celsius cancels out with this, and we're left with joules. But the equation/question is asking us for kilojoules. The question is asking us for kilojoules. So we're going to have to multiply by the conversion factor to get this answer in kilojoules. So we're going to get the Q1 is equal to negative 21, and then we can say 0.057 kilojoules. And we'll worry about sig figs at the very end. So this is going to be Q1. So now that we have Q1 segment, we find ourselves at 0 degrees Celsius, which is the freezing point. So now we're going to want to understand/find what heat is being generated during this actual process of freezing. So we know that there's not going to be a change in temperature because we're staying at 0 degrees Celsius. So that means we're going to want to use the other equation for heat, which is heat equals the number of moles times the change in enthalpy. So to determine the value for Q2, first we're going to find the number of moles, which we do by multiplying the given mass times 1 mole over the molar mass of water, because remember we're starting as water, which is 18.02 grams. And then we're going to multiply that by the change in enthalpy. So as you can see here, we have 4 different values for change in enthalpy, but we know that we're going to want one that's negative because it's going from liquid to solid, which means it's becoming more ordered. So we also know that it's going to want to involve a solid, because obviously it's going to end as a solid. So once we have both those things, we can say that delta H solid is equal to negative 6.02 kilojoules per mole, because that's given to us by the reference table, and we know that it has to be negative. So when we multiply this out, we get that Q2 is equal to negative 51.781 kilojoules. And this is not joules, this is kilojoules, because as we can see, the grams cancel, the moles cancel, and we're left with kilojoules. So finally, our last Q value is going to be Q3 because we found Q1 and Q2. And this is also going to involve a change in temperature because we're going from 0, which is the freezing point, to the final temperature, which is negative 5.5. So we know we're going to use the same equation that we used to find Q1. So we can say that Q3 is equal to the mass, which is 155 grams, times specific heat. But we're not going to use the same specific heat because now we are a solid. So we're going to use the specific heat for ice because that has changed. We're no longer a liquid. Joules per grams degrees Celsius. And then our change in temperature is also different. Our final temperature is negative 5.5 degrees Celsius. And our initial is 0 degrees Celsius. So we multiply this out, and we get that Q3 is equal to negative 1,781.725 joules. And then again, we're going to want to multiply this by the kilojoule conversion factor. So we get that Q3 is equal to negative 1.7817 kilojoules. So here's Q2, here's Q3 that we just found, and we have Q1 up there. So to find the Q total, again, we're going to add this all together. So we're going to say that Q is equal to Q1, negative 21.057 kilojoules, plus negative 51.781 kilojoules, plus negative 1.781 kilojoules. So then we add that all together, and we get the Q total is equal to negative 74.6197 kilojoules. But now we have to worry about sig figs. So we look back at the original question, and we see that the limiting value is going to be this negative 5.5. So we're going to want 2 sig figs in our final answer. So we get the Q total is equal to negative 75 kilojoules, because we're going to want to round. So that's our final answer. And to recap, when we are asked to find the total heat involved in a freezing curve process, we're going to want to break it down into different segments. The first segment we're going to want to do is starting at the initial temperature, going down to the freezing point. So I'm doing these arrows in red again just to make clear. And then once we're at the freezing point, the next segment is going to be the one involved in changing the state of matter, no change in temperature. And then finally, the last one is going to be cooling it to the final temperature that we are given. And then we add those all together to get our total Q, which is given right over here.